Hi everyone and welcome to another day, another class of data analytics. Today we are going to keep going on Python and learn some very useful concepts for Python. So let us begin. So last time we were talking about the basics of running Python. We did a print statement, we did the very classical hello world statement. And so today we're going to basically expand on that, talk about how to document your code and comment code. We will talk a little bit more about variables and the different types of variables there are, and a little bit on Whitespace, which I did mention something, or I hinted at something last time when we were talking about indentation. Okay? But before I do that, let's go ahead and review syntax and semantics just to make sure that we're still on the same page here. So these two terms are very important for you to know because it allows me to better explain when something is a syntax rule and when something is a semantics issue. So syntax is the grammar or the rules of the language, and semantics is the meaning of what you're writing or of the language. And so a syntax error might be something like a missing punctuation, like a parentheses or a dot or a semicolon, or, well, semicolon not really in Python, but other languages, yes, a colon, or violating things like reserved keywords and things like that I'll talk about. Semantics, on the other hand, is when you're trying to do something, but you write something that is syntactically correct, so the interpreter or a compiler in a compiled language doesn't complain about it, but it's still not what you tried to do. As an example, for the English language, we said things like syntax rules are things like uppercase the first letter of a sentence and put a punctuation at the end of the sentence. Another syntax rule could be that all sentences must contain a verb. Semantics, on the other hand, is we gave the example of the word quickly. So maybe you're writing a sentence that says, I quickly eat food. But you happen to write a little bit sloppy, and instead of writing the word quickly, you write the word quietly, or it looks like quietly, but you meant to say quickly, right? So in this case, the word quietly, the sentence reads now, I quietly eat food. It's correct. It's a syntactically correct sentence. Both of these are syntactically correct sentences. However, the bottom one has a completely different meaning than the top one. So the semantics of the sentences are technically different. And so you can see here how one of the sentences is totally meaning something than the other one. However, from a compiler or interpreter point of view that is checking your syntax, these will both pass that. And so things like this can happen a lot in programming, and those are the bugs that we all hear about that appear because it's very hard to be as thorough and check for these. Like if the compiler was able to say, okay, this code compiles only when it's perfect and it is good to go and has no bug, then that would be amazing. The code we would all write is perfect. But that's extremely hard to do because compilers or interpreters are not very good at detecting semantic errors. We can try, but it's very hard. If he has no context and you put both of these sentences through and you ask somebody which was the correct one, they're going to be like, well, I mean, they're both correct. Like, what are you trying to say? Are you trying to say that you quickly or that you eat quietly? I mean, like, tell me. And that's the same situation here. The compiler cannot read your mind. The interpreter cannot read your mind. And so it doesn't know that you meant to say one over the other. Okay? So that's the semantic errors. And of course, mathematically, that could be the example of saying 2 plus 3 is equal to 5. But what you really meant to type was 2 plus 2 is equal to 4. But you typed a 3 instead of a 2. So both of these are correct operations, but really you were trying to get 4 out of this, not 5. Okay? So as examples of what we did in code, we went ahead and we did a hello world program. We talked about using the comma to separate arguments, and we talked about how this is a function. A function is something that you are, we had a whole spiel about libraries, right? Of using a library to be able to save ourselves from having to write every single excruciating step on a program, right? We use libraries to save our sanity and time. And so in this case, the print function is something that is done by someone else for you. You don't even know how it works. There's this concept known as abstraction. This concept of abstraction is very useful, and we talk about it when we talk about object-oriented programming a little bit in the future. But it's the idea that you don't need to know how the print function works. You just need to know that it exists and how to use it. Doesn't matter the black box behind this, how that works. Doesn't matter if like you know, this has a million lines of code behind it to make it work, or 5 lines of code, doesn't matter, don't care, don't need to know, I'm good to go, right? You just need to know how to use it. In this case, how do you use it? You list the arguments that you're trying to print, you separate them with commas, and you know that each of these will be separated by a space, unless of course you modify some of the arguments that it allows you to do. We will play around with this print function later on and try those out, try to change things like what separates them and whatnot. But for now, I'll just give you a quick example and move on. So just to give you an example, let's try to use a separator. So normally the separator is a space. So if I do something like this and run this code, I believe it should do the exact same thing it's done before. As we can see, this is when we ran it last time, and this is when we run it now, and they're basically identical. So yes, the separator is indeed a space. However, let's go ahead and switch that with an underscore. And let's try running the program again and see what happens. This time around, if we look closely here, we can see that between the word world and the word from, there's an underscore instead of a space, and similarly under the data analytics and 621 parts. That is because there are 3 arguments here, or parameters. Now, I keep saying the word argument, but I'm going to start using the word parameter because that's the word that we use in Python. So it turns out that these are parameters, and this is parameter 1, parameter 2, parameter 3, and technically this is parameter 4. However, the function itself expects this special parameter not to be printed, but to be used to define some part of this function, right? This black box of magic happening behind the scenes has a special case where if you feed that as a parameter, it knows that it's supposed to be a setting for how to print versus like actually printing the word sep. What if I wanted to print the word sep like that? Well, I could write this in quotes like I was showing you today. So if you put quotes around something like this, then it understands it no longer as some code, but as a string. So these are called strings, and you can use single quotes or you can use double quotes. So if I go in and run this, you will see here that I'm actually literally printing the word sep, and I've lost the capability of doing the underscores. That's because this is no longer being passed as an argument, excuse me. But it's being passed as it's no longer a special parameter, but now it's just a string, okay? But even so, as I had it before, notice that I have these little single quotes here. As I said last class, it turns out that in Python you can use single quotes and you can use double quotes to signify the beginning and the end of a string. Don't use one and the other, so don't use like a single quote and then a double quote at the end. Use one or the other, like 2 singles or 2 doubles, beginning and end at the same time. Otherwise, you will confuse the interpreter, and they won't know which where's the beginning, where's the end, and what is happening. Like it'll complain at you, or it won't print what you expect. It'll just assume that that's part of your string. In fact, you got to see that when I did the double quotes here, because now I had a mixture of them. So it's okay because it's like, well, you started with a double quote, so I'm expecting another double quote to end this string, and it has it here. But if I put a single quote here, you can see how this would get confused with this single quote, right? Similarly, suppose that it turned out that we used that as the argument for the separator. Let's see if that actually would run, or if it would complain. Let's try it. Okay, so that runs, perfect. So if I use single quotes here, apologies, then I ran it, it would run okay. However, if I try to use double quotes, like as I was doing before, you can see how this can become a bit of a problem. If I try to run this right now, it's going to give me an error. Oh, actually, it didn't give me an error, but it's not printing what I expected it to print. As you can see, it went ahead and printed sep equals, but it didn't print either single or double quotes as it was doing in all the past scenarios. Either was printing a single quote or a double quote, right? So I'm actually surprised it didn't give me an error. I was expecting an error, but okay, interesting. I won't really explain to you why that is the case right now, but what I will explain to you is why we're getting this printed instead of this. Well, because you're using these quotes, and then you're also using these quotes outside and they're the same type, it just assumes that this is ending the string right here, and then that this is like its own string, and then that this is no longer anything, it's just emptiness. In fact, there really should be a comma there, but there's not. So if I want to put an A here, let me just see what happens. Did it print out the A? Yeah, so I guess the print function is flexible enough that it doesn't ask for comma between arguments, although I would discourage you from doing that because it's just bad coding. You know, I talked about you want your code to be readable. There's certain things you should do, and an example of that is separate your arguments with commas. But anyways, that's, you know, what if you were insistent upon using double quotes, but you still wanted this to work? Well, you can use what's known as an escape sequence character, which is whenever you're trying to work with, whenever you're trying to, hold on, sorry, I switched over. There we go. Whenever you're trying to print out a special character that cannot be printed out because of some reason or the other, such as in this case, because you're trying to put a double quote, but you're also using double quotes to signify the beginning and the end of the string, you put this backslash in front of it, and now it tells you like, hey, this is not a quote to end the string. It's just trying to print an actual quote as part of text. And so that will actually, tell the interpreter, like, print them out. Don't actually consider that to be the end of the string. And then you can see that fixes that. And you can do the same thing if you're doing single quotes. In fact, if I leave it like this, it'll also work out. So if you want to be extra safe, whenever you want to print out a quote or a single or double quote, just put that backslash in front of it to avoid issues, okay? But that's a little bit too specific for what we're trying to do. Let's go back to this now. As you see, if I go in and put in a different character in there, then it fills it out. It fills the spaces with X's instead of spaces. So what I'm trying to get to here is that these functions are customizable based on what you're trying to do. We don't need any of this. We could just go back to just having the 621 as long as you're aware that it's going to use a space to separate each character, right? And if that's what you want, or if that's good enough, then that's it. That's all you need to know. So that's the beauty of some of these things, that you are able to use the easy or simple or default version of a function, but it might have a lot of extra features that you can customize to really get the best experience out of it. And the same will apply when you talk about data analytics, like machine learning libraries and things like that. You're trying to run like a support vector machine and do machine learning on it. At the very basic, you need to feed it the data and maybe like 2 or 3 settings, but that's it. However, it might allow you to feed it like 50 different settings to really tweak the thing, to optimize or to do something in specific, right? But you don't need to know that. As long as you know the most basic version of it, then at least you got something. And so that's kind of the nice thing about this, that you can get really fancy, but you can also keep things simple. Okay, so let's talk about commenting, okay? Because that's an easy one to talk about. So let me go ahead and bring this back to what we had before of just hello world, and talk about documentation and self-commenting code. So I already talked to you last class about self-commenting code, and I went ahead and said this example here. So I said, okay, the one here, so this right here, is technically the same one as this. Both of these codes are identical, or at least they can be. They don't have to be, but I'm saying I could write code that makes both of these do the exact same thing, which is to check that if a computer is on, to start doing something that codes, okay? However, I think you'll agree with me that the left side one is a lot more readable than the right-hand side one, okay? Why is that the case? Well, because the left one tells you that if computer on, which literally, if I'm telling you in English, if computer is on, that's checking whether the computer status is on or off, right? If computer is on. Like it almost reads like normal English. And then the function beneath it, which is a function similar to the print function, but in this case it's called start coding, is some function that's going to do something. However, based on the name, it sounds like it's going to start coding, right? Let's do other examples of that to better explain to you what I'm trying to do here. Let's just say that you were trying to say like a thermostat, okay? So if temperature dot greater than 80 colon start AC. Okay? So if I ask you, what do you think this code is going to do? And you say to me, well, this code is probably going to start the AC if the temperature is hotter than 80 degrees. Fahrenheit, probably. But I hope it's Fahrenheit. If it's Celsius, then that's a hot room. Let's put it that way. And you would be correct. I mean, I could also make this like not have anything to do with temperature, AC, or greater than, but that would be very bad coding, right? You want to write the code that is easy to read, and this is an example of that. If you name your variables correctly, if you do your functions right, you could write code like this. Now, I would personally write a different version of this code, and I'll show you what that would look like. I would say something like, if temp greater than 80, start AC. So I would actually write that version of the code. I'd actually use the mathematical symbol for greater than, because while you could write a function called greater than that will do the same job, you know, I think that the bottom one is less writing and is still readable enough for someone that has that basic math knowledge, which pretty much most people know that that's a greater than symbol, right? So both of these are very, very it's called self-commenting code because the code tells you what it does without you having to know anything else. However, there will be times when the code may not be this readable, okay? The code might be something like, let me see an example I can think of. If room T greater than trigger temp, devices start devices dot maybe AC dot start. Like that, okay? So if you see code like this, there's some things you could do to improve this code. So for example, instead of a T variable, you could say something like temp, and I'll explain variables and whatnot later today, but I'm just trying to make the point about readable code right now. So I could modify the code a little bit like this. And so the code says if room temperature is greater than the trigger temp, then it's the same thing, start the device, start the AC, right? But what makes this code a little bit less readable is the following. We don't know what the trigger temp is. So the trigger temp might be 80, but it might be 78. What I'm trying to say is that any temperature above that value is what's going to actually start the AC. But if it doesn't go over that, it doesn't start it, okay? So that would be an example of something that is not completely readable. However, the reason why I might choose to do this instead of putting an 80 there is because this is a number that I may want to be able to modify later on. Like maybe I connect this to like a smart home, and then like I want to be able to send from my phone the temperature that is going to trigger it. So like maybe before I get home, I'm going to lower that temperature to like 78 or even lower, so that like, you know, it triggers whenever it goes over 78. Or maybe it's going to be based on the time of day, you know, because I'm not home during like work office hours, then maybe like I raise that temperature or I lower it. So I don't want to what's known as hard coding a value. Hard coding a value means that instead of making something variable, you just put a number out, which means that it's always going to be that number. It's not recommended to do this unless you're doing something quick and dirty prototype, because you can see that it can be a pain to go back and change it. Like if you have this 80 number used in like 40 different places, and all of a sudden you want to change it to like 81, you got to go and find all 40 different spots you use the number 80 to change it. Whereas if you use a variable, you just change the variable's contents, like in math, right? So ultimately, another example of where things might not be readable is here we have this device, AC start 78. So I think that it's readable to say that 78 means the temperature that we're going to start the AC until it gets to the temperature, then shut it back off. So like maybe it's like we're going to cool it down until it gets to this temperature. Or maybe this is the temperature that is supposed to go at lowest for before it shuts off. But this is something that may not be so readable. It might be readable to me because I knew what I was thinking when I wrote it, but it might not be readable to you because you're not in my head, and that's perfectly fine. Or simply, I write this, I go sleep, wake up tomorrow, and I forgot what I wrote, and I'm like, what did this even mean? That also happens too. Gets all of us. So in scenarios like this, self-commenting code is not enough to explain what a code does. And so what can be very useful to add there is comments. Comments in Python allow you to document your code and add more information that can be very useful, not just for you, but for others who are working with your code to know what in the world you were trying to do with that line of code. And so the way you write comments in Python is you use the pound sign, or I guess what the cool younger kids call it, the hashtag sign, right? I still call it a pound sign, but I guess later generations moved to hashtag. So you put a hashtag or a pound, and then you can write anything after. So like you can say, this is a comment. And it is true, this is a comment. As in, like, if you put this anywhere in your code, then the compiler or the interpreter, in this case, because Python, will ignore it. It will not do anything with this. So as it's reading code, you know, it's like, okay, this is code. It's checking all the syntax of this code. And it's like, well, it's gotta follow certain rules, right? However, when it hits this pound sign, it ignores the remainder of this line. It'll look at the next line, but for this line, it ignores that and moves on to the next line. So it's like checking code here, gets here, it's like, oh, ignore this, and then checking code here, checking code, and so on, right? So that's what the pound sign will do. It will ignore the rest of the line. And that's useful because then you can write comments there for yourself and for others. So how would I do that here? Well, I could put here a pound and say temp is 80, just as a reference for me. Or you could also say set temp to phone or something. But okay, let's say I can't fit the word phone. Maybe I want to put it here, so I can do the same thing here and just finish adding my comment here. I could also make an entire line be a comment as well. We haven't talked about indenting, so I'll explain why I'm not lining up this to this. Like, you'll notice that there's just like an empty space here. I'll get there in a bit. But if you want to put a comment, you could also put a comment here saying, like, you know, set AC to 78 so it cools house. Or you could put a comment saying, actually, even for the one above it, I would put a comment saying Fahrenheit, just to avoid potential confusions. That's a good comment, actually, I would put in there, Fahrenheit. And like, you don't need to put anything else. Now it says if temp is greater than 80 Fahrenheit, start AC. Now this is beautiful. This code, I could feed it to a little kid who just learned how to read, and he'd probably tell me what this does. Well, maybe he doesn't know what the word Fahrenheit is, but let's just say he knows Fahrenheit. Then he would tell me what it does. Okay? That's what you want. You want to have that code be that easily readable. And you can do that between self-commenting code and comments. Okay? If you want to write a multi-line comment, you can just literally put a bunch of these like this and say something like, this is multi-line comment, like multiple line comment, right? You can do that. It's cool. You know, I accept it. However, you could also use another way of doing multi-line comment, and that is to use 3 single quotes, and then you have your comment, whatever it is, and then put 3 single quotes again to finish it. And while you can do this for a single line comment, I suppose, where you really kind of get advantage of this is if you make it multi-line, because you can just literally put this and then just put this somewhere else, and all the stuff in here is going to be ignored by the interpreter. So as it reads this, it's like code, checking syntax, code, checking syntax, stops. It's like, okay, ignore. Okay, I see these again. All right, let's start actually looking code again. And it's like code. And it has basically ignored all of this, which means you can write whatever you want, okay? So it's always good to add comments. It does not slow down your code at all. It makes no difference to your code. However, it definitely speeds up your understanding of the code and you trying to tell others what your code does, which is very, very important, okay? Especially when you're working as part of a team. But even for yourself, like I said, it's very common. You're tired, you write some code, maybe it works, maybe it doesn't, but you go to sleep You go come back the next day to work on it, expand it, fix it, whatever, and you literally look at it and you're like, did I even write this? Or like did this just like magically appear? Like where am I, like you're like Jason Bourne that moment. You're like, I don't remember doing any of this kind of thing. Okay? That happens to all of us. I will emphasize this one last time. Document your code. Please. Like tons of programmers do not document their code. And frankly, people like it's a courtesy for others, but like in general, I can know when somebody's like a good programmer just by the way that they write their code, but also by the way they document their code. Because like somebody documents their code means that they were either working with a real team and they learn good manners, or they've been coding long enough, or they're serious about their code. When you see somebody not document their code, it's the first sign of somebody being an amateur, and usually that's not a good start, because that means their code is also really bad, which means it's probably not that self-documenting. So it's like, it makes it even worse, okay? So document your code, please. Okay? That's my spiel about documentation. So let me just show you an example in code, actually, of me doing that, okay? So if I go in here and write, this is a comment, and I run this, you will see that I am just getting my hello world. I could also do it here, another comment, and here's the third one. Multi-line comment, yay, just like blah, 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 okay? I run this, but I still only get hello world. If I do another print, like data analytics rocks, and I run this, you'll see that I am still only getting 2 lines of code, or sorry, two messages out in the terminal that say hello world and data analytics rocks, but it's ignoring all of this stuff, okay? However, when can I break this? Well, I gotta make sure that I'm putting them at the end of the line. So like, I can't just like in the middle of this, like say a comment, because now it's going to ignore the rest of the line. So like this will give me an error because I have this print statement, but I don't have like, no, it doesn't give me an error because that's horrifying. But it just doesn't work like the way I expected. I guess to give it an error, if I had the parentheses in there, so like I guess if I put this like that should give me an error because of the parentheses. Good, thank you, Python. Okay, so make sure you put your comments at the end of the line, unless you want bad things to happen. Or put them on their own line, or use the multi-lines. I do encourage you to avoid using the multi-line unless necessary, because one of the nice things about having the multi-lines available is like if you're writing a bunch of code and you want to comment a chunk of code to test something else, it's very easy because you can just like go in and write your multi-line and bam, you just commented out that line. So if I run this code again, I only get the hello world, right? So as you get like long pieces of code and you just want to temporarily disable them, one of the best things you can do for that is comment the code out. It's a very common procedure you do. So like you're writing some code and you're testing, or you simply want to see what some code does but not run the entire thing because it takes a while, literally just add a pound in front of it. Bam, I just commented that out. So now I can go and check my hello world part but not have to see the other part. Or I can comment this out and check the bottom part, and now I see the bottom part, right? So that's good for single lines. You can use your pounds for that. But if you want to comment out like a bunch of things, so let's just say that we have that. So if I run this code, I'm going to get data analytics rocks a bunch of times. But like, let's say I want to comment out all the data analytics rocks temporarily because, you know, I'm testing something, and like, since you're doing data analytics later on, these functions you're calling might take like, you know, even if it takes seconds, it's still seconds. I don't feel like waiting, right? So, you know, one thing you could do is you could comment them out manually. Like, okay, it's me commenting out manually, Control F5, and now I did that. So, another thing that you can do is there are some keyboard shortcuts that you can do to like comment everything out at once. What's the one for VS Code? Let me check out VS Code comment out block. It's like Control K or something. Control K. I think it's Control K. Nope, that did not work. I don't want to break this. Hold on. Uh, Control / I'm seeing on the internet. Shift Option A for Mac, and for Windows Control / Okay. Try Control L. Nope, I don't know. Whatever. But anyways, there are ways that you can comment out blocks that way, and what it'll do, it'll literally just add the pan in front of it. However, if you don't want to do any of those, you can also use this multi-line thing by just putting the 3 quotes there and 3 quotes at the end, and now you are able to comment out entire blocks like that. Okay, so that is also a convenient one. By the way, you might have noticed that when I do the 3 quotes, it adds 3 more. That is because the autocomplete of the IDE is helping me speed my life up by being able to then like write comments here, right? And that's why it's auto-completing that. That's a pretty typical thing. It's like if I write print, it also closes it for me. The idea is to make it go faster. That's the whole point of that. Okay, so that is commenting for you. Very useful. You should always use it, and not just for documenting, but if you need to comment out something. So whenever you hear the expression comment out this line of code, it just means like, okay, disable like a line of code while you're working on fixing something else, or if you don't need to run that piece of code right now. Okay, so that is commenting. Moving on, let us talk about Whitespace, at least a little bit. So the concept of Whitespace is spacing. So things like space, indentation, tabulation, or enters, line feeds, and whatnot. So let me write those down. So when you think about Whitespace, you think about spaces, like literally spaces between words, that kind of thing. You think about tab, indentation in general, and you think about line feeds or carriage returns. Although line feeds are the ones that we properly use, but like I believe Windows has carriage returns, and Mac has both of them or something. Okay, those are the 3 main things that we think about with Whitespace. Can't really think of any other ones, but yeah. So an example of spaces is like if you say hello, and then you put world. And there's like 1, 2, 3, 4, 5 spaces here. Tab is actually like a tab. So tabs can be different lengths depending on how you set them up. But let's say it's 3 for a tab. So, but this is 1 click basically. Okay. And then line feeds is like if you say like hello world. And line feeds, by the way, if you ever want to print out a line feed in your strings, you use that escape sequence character that I was talking about, that \, but you don't use it with the quotes like you were doing before. You use it with an N. And so this will create a line feed. So let me show you what that looks like. So let's say I want to print out hello world in 2 different lines. First of all, let me comment out. See, we're using that phrase. A couple of these, just so we have a little more space here so we can see it all. As you can see there, we can see it all. So let's say that we want world to be in a different line. What I can do is I can put a \n like that, and then run the code, and you will see that hello world are on a different line. That is because it takes that escape sequence character. So let me write that keyword down for you. So the \, in Python is known as the escape sequence character. Okay? And the character means a single letter per se. Okay, the word character, that's where it comes from. There's a special list of them, which is the ASCII table. We'll get there in a bit. So what I'm doing here is as part of the string, and I gotta make sure that I put it again in quotes because it's part of a string, and a string is again just a set of characters that is going to be printed out of to the terminal or saved somewhere if you're saving it somewhere. And then basically I am saying, okay, add that line feed here. Okay. However, you'll notice that the world is kind of like there's an extra space there. Where is that coming from? Well, that's coming because you got a space after the line feed. If you don't want that, then you just got to get rid of that like that. And if you do that, even though the letter N and the letter W are touching each other, this only applies to the immediate next character. So the escape sequence character only applies to the next one. So when you're doing like a quote, you do something like \quote, that's only applying to this quote, whereas this is only applying to that. So if I do this now without the space and I run this, then you'll see now that that space is gone. So whereas before I had the space, now I don't have the space. Of course, if I really wanted a bunch of spaces, a bunch of spaces like that, I can do that as well, okay? I can also mix and match. So let's say I want to print out in that line a quote and then maybe another line feed after that. And maybe I want to do a line feed here for some reason, just some really hyper on line feeds. Run that and we get this. So as you can see, hello, line feed, and then we have a quote that we're using an escape sequence for. Although we didn't have to technically this term, although if we did this one, we would definitely have to. So if we did that, that would definitely have to run it, right? As you can see there. So then we get another line feed, then we get whirl, line feed, and then D, okay? So that's what line feeds do. That's how you use them in Python. But this actually applies for lots of programming languages. So that's your whitespace, okay? And so the reason why I want to talk about whitespace is because some programming languages like C++ or Java are what is known as whitespace insensitive, which means that it ignores all whitespace. I mean, you need to have whitespace to separate things. So like if you have two variables or two things in there, use at least one form of whitespace, whether it's one of these three, tab, space, or line feed, to separate things. But it doesn't care how many, like if you have 20 spaces versus one space, it doesn't care. If you literally write your entire program in a single line that's like super, super wide, then it's okay. It's like, yeah, that's fine, cool. As long as you separate them with a single space. You could also do the opposite. You could literally write your code in like a million different lines by putting enter every time that you wanted to have a white space. You could do that too. It's going to look nasty, either version of that. Of course, they're like the extremes, right? But you can do a mixture. Whitespace can make or break someone's code in the sense that, like, the appearance. Like, a really good coder could make code look horrifying, unreadable by using really poor whitespace practices. Or it could make like code look beautiful and super easy to read. So when it comes to Python, however, Python is not whitespace insensitive. It's pretty sensitive about whitespace because it turns out that it uses it for scoping rules and in general to understand whether something is inside a function or outside a function, inside an if statement or outside an if statement, and all these different things. So as we go over the language, you will see me use space as an actual way of separating things. And while it's okay when you have like individual spaces, yes, you can have 3 or 4 spaces between parameters in a function. So like if I'm saying print hello, and then I put like 2 spaces here, and I say world, like that, it's okay about that. It's not gonna be that picky about that. So if I say that like hello, comma, space, and then world, it won't complain about that. It'll be, and plus it won't print it out because again, that's not part of what it's printing. It's just separating the parameters. It won't complain about that. However, if I put this in a completely different line like this, because it's inside a function. When it's inside a parameter like this, it actually is okay with it. Unfortunate example of that. But in a lot of cases, it will not be okay with this. It will yell at you really badly. We'll see those examples when I show you variables and assignments, okay? So you have to be careful about how you handle whitespace, okay? Obviously, you should be making your code look pretty, but what I'm getting to is, big issue that people complain about Python is that lines become really long horizontally because of trying to avoid issues with whitespace. And I'll show you how you can use the backslash to get around that and other things later on. But I'm just warning you, you have to be careful about how you use whitespace, okay? This will all make more sense when we talk about things like if statements and whatnot. Okay, so let's talk about variables now, finally. variable. This is where things get to start a little bit more interesting. So let us forget for a minute Python and programming and go back again into math. So I showed you some variables last class. We did the whole f of x, right? So we did f of x is equal to 2x plus 5, right? So what is this? Well, that's nothing more than just algebra, right? So hopefully you all remember some of your algebra, basic algebra, I hope at least. And so, you know, if I tell you something like, okay, kids, what is the solution to this problem? If I said 2x, you know, 10 is equal to 2x, you know, what is x equal to? And then you're like, x is equal to 5. Yay, happy, right? Great. Well, it turns out that that's the reason that algebra is very useful, and that is for programming. Because when you're trying to make something automated, you want it to be able to handle multiple cases, right? You want it to be variable. And so it turns out that using algebra to generate formulas that will work for multiple cases is literally like a great uses of algebra. For example, suppose that you wanted to make a function that calculates the area of a rectangle. What do you need for that? Well, the area of a rectangle contains 2 dimensions. Hold on, make my rectangle actually pretty. And that's going to be your length and your width, right? I mean, you can call these A and B, whatever they matter. But these are 2 variables, right? And then if you're trying to write a formula or a function to do that, then what you're saying is that the formula is going to be based on W and L, and it's basically going to be the multiplication of those, right? You could write it like that, or you could write it like the little times symbol. I like to use a dot for some reason. It's just a thing I got used to. Hopefully I don't anger our math friends in here. But yeah, I like to use the dot. I kind of have that linear algebra mentality from the machine learning side. So maybe that's why I use it. So yeah, so you're writing your formula like this, right? And this allows it that once you code this, it doesn't matter which triangle dimension or which rectangle dimension you feed it, it will calculate you the area of that rectangle, right? And so yeah, algebra is extremely useful for like a lot of things that you're going to be working with, okay? Like, it's not just the fact that you're doing data analytics, which by nature is numbers, but like, think about it. Computers, as I said earlier, ultimately translate your code into a bunch of zeros and ones, right? That's known as binary. And so at its natural habitat per se, computers are nothing more than numbers. And so the language of computers is the language of mathematics. And that's a beautiful thing, by the way, because it's an international thing. And so ultimately, because that language is mathematics, the tools that you learn in mathematics will help you become a better programmer. So, whether it's something as basic as algebra to, like I was saying earlier, linear algebra and like matrix multiplication, all these things, it all boils down to you're just working with numbers. This is base 2, but this base 2 binary can represent things in base 10, which is like our number system that we use every day. So ultimately, math tools are going to come into play, right? Now, that's not to scare you all about like math. Oh no, I have to like refresh my math from 50 years ago or 5 years ago, however long you took this classes for. No, not saying that. But you should definitely at least remember some basic algebra, right? Because hopefully making the transition from this to this is something that you can do, right? Because that's what you want to do. If you want to compute something, you need to be able to create a formula, write down a formula on a piece of paper, and then you can code that very easily. If you have a hard time writing the formula, and it's, I mean, obviously if it's something super complex, like you're trying to find out the area of this irregular shape or something, or doing like a calculation for like a statistical calculation that requires like a lot of operations, yeah, sure, of course, writing like an algebraic function for that is not easy or trivial. But most of the times you're not going to get to that level of extreme. And if you are, remember what I said earlier. There's probably a library function that does it for you. You don't need to calculate the covariance of something, by hand. There's probably a covariance function you can use where you just feed it the data and you're good to go. So again, don't freak out with the algebra stuff, but it's really good to think about it that way, okay? And the reason for that is because when you're dealing with data in a program, you want to store that data in the program, right? If you intend on multiplying two things together, you need to store the two things you got to multiply first in the computer and then tell it to do the multiplication. So how do you store data on Python? That's what we want to do. And that is done through variables. Now, there's a lot of ways to load the data into Python, such as reading from a file, reading from input from the user in the terminal, or hard coding the data into the actual program itself. So let us just for today work with hard-coded data, and then on a different day we can talk about user interactive input and also loading from files. Loading from files and running from files is kind of its own nice little group of things to talk about. So we'll talk about that one day. And then interactive input we will talk about next time. Okay? So let us do hard coding for now. So let us say that we would like to store a couple of numbers or other pieces of information. So for example, let us say that we want to store the number 80 in there. Let us say we want to store the number 50 in there. Let us say that we want to store the word hello. And let us say that we want to store the number 352. Okay? Now these numbers are what are known, I believe, as integrals in math, but I'm going to be calling them integers in our case here. Okay? Integers are going to be numbers that are negative, positive, or zero, but they're whole numbers at the end of the day. Whereas this is not technically an integer, right? Oh gosh, I'm worried about saying the wrong thing since we have people that are math experts here. But let's just go with the word real number for this, okay? Although real number, I believe, can be, or can they be? There's write down in the comments or let me know, because I forget what you call things like this that don't have an exact number to them. I don't know if that's a real number or that has a different category. I can't remember. Discrete mathematics, forgot about that stuff. But for now, let's just call it a real number, okay? And just pretend that's the case. What makes it different is, of course, that there's decimals involved. However, this is an exact number, right? Whereas something like square root of 2 is not an exact number. Okay? So, what do we want to store these kind of numbers in Python? Okay? Python is super, super cool about this. Like, you can just make a variable, whatever you want, and then store any kind of data in it, and it'll take it. It'll take it. Very nice. So, like, if you, let's say we call a variable var1. Okay? If we want to store this information in there, all we have to do is literally put the assignment operator. What's the assignment operator? It's the equal sign. However, it's dangerous to call it the equal signs because later on when we're trying to do logic and we're trying to check equality, so whether like two things are equal, like two variables have the same value and whatnot, you actually use two equal signs for that. So I'm never really going to say equals for this. I'm going to be using assignment operator, okay? So again, this is known as the assignment operator. I'm truly bothered that I remember what that is. The number and scale for that. There's a missing. It goes from integers to reals. I feel like I'm missing something in between. Irrational. That's the one. So okay. So I believe. So this one, square root of 2, is irrational numbers. I think that's what it's called. So I think these are okay to be real numbers, but then these are, I think, irrationals. I don't know. Then there's like imaginary numbers and all of those fancy stuff. But for now, let's just hope that I'm right on that. Okay. So, excuse me. I kind of want to sneeze. Maybe it's because I'm lying and I don't know the math stuff. Okay. So that is known as the assignment operator, and then this is actually equality. Okay. With two equal signs. But again, this one we are going to kind of set away for now and talk about it another day, okay? Maybe later today, but not right now. So that's just going to go away for now, okay? So if we want to assign something to this variable, what we need to do is put it on the right-hand side. So if I would like to assign the 80 to this variable, all I have to do is take my 80 and put it there. And this line of code will now store the number 80 in variable 1. So now, or go back to my print function, and I say, please go ahead and print bar1. This will actually print out to the terminal the number 80. Let's try it out really fast, just to make sure that I'm not lying to you. So if I say bar1 equals 80, and then I say print bar1 from the code, you can see down here that I get the number 80. I can make my output pretty by saying the contents of bar1 are, put a comma, and then that, run that in. You can see this looks a little pretty now. Okay, so already you can see you can make code look nicer. Now bar1, you know, that's not a really nice variable name. So again, if you're making self-documenting code, let's say that 80 in this case is temperature. So maybe you shouldn't call it bar1. Maybe you should call it temperature variable, or just temperature, or temp. So this brings an interesting thing to talk about, and that is what is known as the identifier rules. So variables, Python's really relaxed about how you can name variables. A little too relaxed if you ask me. However, there's still a couple of rules and recommendations to choose when naming a variable. First of all, the variable is made up of a bunch of letters and characters. We call them characters because they include more than letters, right? So they can be numbers or letters as well as other special symbols. So in our case, identifiers, which is things like variable names, function names, those are the two main uses really, have certain rules. And those are that you can only use the letters A through C, uppercase or lowercase, doesn't matter. And you can only use the digits 0 to 9, and you can only use the underscore. Okay? I believe that's the entire rule set, but we can check that later just to make sure I'm not missing anything special. And there's one more rule about it. For the first character, or think of it like the first letter of the identifier name, you can't use numbers for that. So you cannot call your variable 1 bar. That will not pass. That's a syntax error. These are grammatical rules. Remember the word rules in here? You know, that's your syntax, which is great because that means that the interpreter will tell you like, yo, don't name your variable like that. Okay? You can, however, name your variable var, you can say v2, v1. You could even say underscore v, or actually I think you can just make a variable called underscore though. That brings up a good point. So while you can use the underscore in your variable names, and you can use it in the beginning, it is highly discouraged to do that because you reserve that for like special system variables, and you might run into issues if you do that. So, you know, I'll put this in like a yellow cross kind of thing, where like I will discourage you from doing that, but it's not illegal per se. Free country, you know, do what you want. However, a good usage of the underscore is, for example, if I want to name a variable high temperature. It can be very, very nice to use it to separate like letters within the variable name. So this is one single variable. The reason why I'm making such a big and long variable name is because it's very nice and clean to read. Now, this does bring up a good point. When you're choosing names for variables, you have to take into account that you want to make them readable, but you also don't want to make a book. And so if you know, for example, let's say that I wrote my variable as high temperature for AC. That's a really nice variable, self-commenting, you know, like I totally understand what this variable is for, but like imagine having to write code with this. Like you can see already in the page here, like it takes like half the page. Writing a function with this, like, you know, the earlier thing that you're writing, like if high temperature for AC greater than 80, like, geez, this barely fits in here, right? Now imagine if I have to like modify this variable or other things, or is this part of like some bigger piece of code. just a single act of having to type this whole thing, even if you use autocomplete, like it's just not a good thing to do. So you have to find that balance, right? So that's where I found the balance of temp. The rest of this is kind of self-documenting. I think this is more than enough. High temp explains temp is temperature. If you really need to clarify the AC part, put it as a comment somewhere once and not again, and then people will see it once and be good to go. So you got to find that balance, you know. It's you're an artist at the end of the day. Writing code is more than just like functional stuff. You want to make it look good. You want to take pride in your work. So these are things you just do to make it look pretty. Okay. Now, you know, I say that as a CS person. As someone that's not a CS person who just wants to get the average of something, I understand and respect when things are not looking this pretty. But I'm still trying to instill you some good habits per se. You know, and maybe you pick a couple of them up, maybe you don't. You know, because at the end of the day, you know, you want to contribute to code that looks good in the world, not code that is like painful to read, right? Because this helps you too when you're trying to read your own code or share it with others. So anyways, that's a good example of using for the underscore, is to be able to write more descriptive code names and separate words. Because I mean, you cannot. So if you see here in the list of things here, there's no spaces as allowed characters and variable names, because if you do this, the computer gets confused and thinks these are completely different variables. It's like, well, I mean, this here is a variable and this other here thing must be like a variable too, right? They're like independent variables of each other. So that might not be what you're trying to do. So don't add spaces. Another thing that you can use is what is known as camel case. Camel case is like a writing style for variable names, where you lowercase the first letter of the name, and then every time you're adding a new word as part of the name of the variable, you uppercase it. Also makes it easy to read and easy for the eyes to see, okay? So like both this and this allow you to easily see it. The advantage of camel case over using the underscore is less writing. The underscore takes time to write and it's one extra character which can add up, over lots of variables. So you save that, I suppose. So I would recommend that you try them both out and then pick the one that you feel more comfortable with. In my personal opinion, I like the camel case more. However, again, that's strictly a personal opinion, probably based on the fact that I'm lazy to write an extra character, which is the underscore. However, I have been known to use the top one occasionally if I'm writing code where it's already been used. Like if you're working on somebody else's code or expanding it, and they've been using all the underscore style, then I'll just stick to that, because the last thing you want is like a Picasso where like you have code that works, but like it was written by 10 different people and they all had their own style. And so you can see very obviously like who wrote what. But at the same time, you're like, oh gosh, like why? you also should have committed to one style, and make it look uniform. Okay? So yeah, that's what I'll say about that. So camel case and underscore. Okay, so also you'll notice that I am lowercasing, and that's part of the style is to lowercase the first letter. It's a good practice to lowercase your variables. You typically reserve uppercasing a variable if it's like a class name. I haven't talked about classes, but once I get there, or other special cases. You also really, even though I use it for the example earlier, you rarely want to uppercase entire variable names, just because in general, looking at uppercase things in the computer is tiresome for the eyes. I feel like the code is yelling at me. So I'm like, yeah, no, don't yell at me, code, please. So I tend to reserve uppercases for things like macros or constants. So what's a constant? A constant isn't really a thing you use a lot in Python, but in other languages like C++, you make variables that never modify. So like, for example, if you're using pi is like a fixed number, right? Well, it's an irrational number, but it's like fixed in the sense that like pi is always going to be that 3.14, right? It's never going to be like 3.18. And so you make it a constant, and it makes the code a little more efficient. And you want to tell somebody that it's a constant, not something they're supposed to modify, so you uppercase it. But these are all style decisions that, again, you do to make your code look good, but you don't have to. Again, it's like, you have a car. You can make that car be functional to get you to work, but you can also make it like, wash it and keep it like nice and clean and like paint when it gets degraded or fix any issues it has, any cracks, It's all about the presentation, which will make your ride more comfortable, or in your case, it will make your code easier to work with and modify in the future. And that's something big to think about. It goes back to the commenting thing. You write code, you think you're never going to modify it, but then somebody comes back and says, hey, can you do this and that? And then you got to modify it, and now it becomes a puzzle hunt. Like, can I find where I actually did this? These are all things that are going to help you make that easier. Okay? So that's the naming convention for variables. So going back to variables themselves, as I was saying, Python's actually very relaxed about variables. A variable can store any piece of data, and it can change the type of data that it's storing. So like if I say bar1 gets 80, so let me go ahead and actually take these and bring them down. So copy and paste. So I got my bar. And let's say that I put an 80 in it. So right now it's holding a number. But I can immediately, or later in the program, reassign what it contains by using the assignment operator again, and then feed it a string. And it'll work fine. Now, what does happen though is that when you overwrite what is in bar by using the assignment operator again here, you are losing this number. This number is gone. The moment you do this, that number is gone. It's out of this universe, okay? It's gone forever. So be careful about that, I suppose. Don't overwrite things you mean to use later. Because like if you were trying to do, if your job was to add 80 plus 50, and you're trying to do that by saying, well, let me put in somewhere the 80, now let me put in somewhere 50. You're like, yeah, but you can't do that. You have to make another variable maybe. So maybe make a bar2 and then put that. And then make a third variable and do the addition. Except you don't do the numbers, you use the variables. Bar1 plus bar2. And while we haven't talked about operators, it turns out that you just write a plus when you're trying to add two things together, whether the numbers or variables. Now you could have also stored this in variable 1, but just be aware that that would replace the 80. This will still work fine because it reads from right to left. So it's not like it's going to get confused, but just be aware that you are overwriting that, okay? So even though that's the end of the story for Python, I would still like to explain to you how different types of variables are handled internally, okay? So while Python lets you have different kinds of variables, there's still different types of variables internally that is how it's working, and it just switches it on the fly. But you knowing what these variables are will come in useful later on for other things, okay? So let me give you a list of the type of variables that Python has. So there are integers, which is abbreviated int. And those are able to hold positive or negative numbers, whole numbers, and there's a range that it can hold. Typically that range is 2 to the power of something because it's holding it in bytes. I believe it's 2 to the power of 31st because because a computer is able to hold 2 to the 32nd, which is basically 32 slots where it can hold a 0 or a 1, and that's how the binary happens. But it reserves that first one for whether it's a positive or negative number. And so that's why you get this range. This turns out to be, I believe, something like negative 2 billion to positive 2 billion. I think it's 2.7 billion, but I don't remember off the top of my head. You can Google that. Okay? That's how integers are held. That's the range. Another type of variable that you have is, of course, the string that we talked about. Strings are going to be characters that are put together. And I guess the abbreviation for that is technically, well, usually there isn't one. You just use the word string. Although I've been writing it uppercase, but it's really lowercase. Like that. So that's just a string, and that's an example of that. So this is like 2, -2, 8, 10. This is things that you put in quotes like hello. You could also use a single character, I suppose. I think that would be right as a string, but I'm not so sure. Because there's also a car. Let me just get rid of those and keep it lowercase. Okay? So there's a character. Okay? What characters are... Let me make this prettier. Hold on. It bothers me. That doesn't look nice. There we go. So you have int. Then we have string. And we have a car. Okay? This stands for integer. That just stands for string. And this stands for character. Okay? Examples of this is like it says 2, -2, 5, 10. Strings are like hello, blah, with single quotes. Cars, on the other hand, are going to be single characters. So like a little piece of a string per se. And so a car is actually kept as a number internally, but you see a character. And what it does is that number represents a table, and that's the ASCII table. Let me go ahead and pull up the ASCII table real fast. This is the ASCII table. You can find it if you just Google ASCII table and then find it. And what you, I know it's really tiny, but basically you have the first column, which is the decimals. So that's the one you should be looking at. And so the numbers go from 0 to 127. So there's 128 of them because you have to include 0 in that. And so the numbers represent a specific character. So for example, what is the A character? Well, the A character is actually two numbers because there's the uppercase one and then there's the lowercase one. If you want to do lowercase, it actually is number 97. So internally, Python stores 97, and that represents an A. And why do we have to do this sort of lookup table? Because remember, this all boils down to binary. All is math. And so math does not understand letters. It understands math, numbers. So basically, we need to be able to translate a number to a character. And that's how it works for both strings and cars. But cars are like the unique ones because there's just a single one. So string is just made up of a bunch of these. As you can see, there's more than just letters though. There's numbers here. So why are there numbers? You might ask if you can just store a number directly. Well, because it's not the same to store a number that is like a numerical representation of something versus storing the number character when you just want to store that, but not necessarily as a number. Okay? That's a little bit hard to grasp, but as we practice, it'll make more sense. You can also see other symbols. So for example, if you want to use like a little dot, or a tilde, or an @ symbol like an email, if you're trying to print out an email, that's number 64. Now you don't actually need to remember or memorize this table, but what I'm trying to say is how internally it works. So if you're trying to like, let's say you're doing some cleanup of data. So you're trying to clean up some text files, and you want to remove everything that's not alphanumeric. So nothing A through Z, 0 through 9. So you can use ASCII math per se to remove everything that is not within that range. So as you can see, uppercase A starts at 65 and ends at 90. So if all you care about keeping is like uppercase letters, then all you gotta do is remove everything that is represented with less than 65 or greater than 90. So we'll do an example of that next class, okay? But that's how characters are held. In addition to that, we have at least one other type that I would like to talk about before we end class. And that is going to be float. Turns out that Python's float are double. For those of you that don't know other programming languages, Python's float are doubles for other programming languages like C++. However, don't worry about what that really means. What I want you to know is that a float in Python can store things that have decimals. So it can also store whole numbers, but it's especially made to be able to store decimals. So you can store pi in there and whatnot. However, there's a limitation on the accuracy. So you can't just throw in a rational number and expect it to be like perfect, right? Because it's infinity. So that means like, I hope that kind of makes sense. Like if you're trying to put 1/3 in here as a decimal representation, we know that's impossible because like it goes forever, right? 0.3333333. And like your computer is not infinite, right? So there has to be a limitation to that, and there is. This uses something known as the IEEE standard for floating point. That's way beyond the scope of this course, but I encourage you to Google it and look how that's made. You know, you can look at what the mantis is and whatnot. It's pretty cool, but it's just too much information for what we need. So just know that if you ever want to store floats or really big or really small numbers, so everything that goes out of this range, so if you want to store like 10 billion in there, then you can use a float for that. So like, you know, big numbers or tiny numbers too, like 0.000001. Okay, so that stands for floating point. And you might have heard the word floating point before when you're talking about a GPU. GPUs are actually really good at floating point calculations, so things dealing with float, whereas a CPU may be more efficient at integer calculations, or just not as efficient with floating points because of the way it works. So that's why a lot of the games use floating point stuff. So yeah, these are some of the types. There are a couple of more out there that we haven't mentioned, such as Boolean and well, Boolean's the last one really that is kind of big. So maybe we'll mention it really fast. So let's talk about Boolean. We'll talk more about Boolean when we do like logic, but it's able to store a state where there's true or false. And that's useful to know, again, when we're trying to do logic, like whether something is on or off kind of thing, or whether something should evaluate to true or false after you do a logical operation on it and whatnot. But yeah, all these variables, you know, you can store them in the same variable all you want, you know, keep changing it back and forth. Can get a little hectic if you do that, so I discourage it. But ultimately, they allow you to store information in Python, okay? So next time, and when we meet in person, online, we will play around with these variables, and I'll give you some examples and I'll record it. So I thank you all for watching. I hope that this is one step closer to your full power of being able to take your Python skills to the next level. So I thank you all for watching, and I wish you a great weekend. Take care and see you next time.